Hi there. Thanks for joining us. This is Space Nuts. We talk astronomy, space science, and sometimes a new cocktail recipe. On this episode, Fred and I will be focusing on Mars. Back in 2023, so long ago, a message was sent from Mars back to Earth, and it's taken a while, but it's now been decoded. What's this all about? Who decoded it? That's a bit of a surprise. We'll look into that. There's a black hole out there somewhere, and it is very, very hungry. It's probably obese, as a matter of fact. And another story about Mars. I nearly forgot. We're looking at its history in terms of its carbon dioxide and the water circulation of the red planet. It's really fascinating, and it could give us a completely different idea of how the planet came to be as it is today. We'll look at all of that and more on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And it's the man of the hour, Professor Fred Watson, astronomer at large, but people are coming up with all sorts of different titles for you, Fred, because even on our social media platforms, people have been having a bit of fun after you announced you were getting out of the public service last week and moving into a new role sometime in the future at a university. But even Hugh in the studios chimed in. He's called you the astronomer in the wild.
Yeah, I quite like that. In the wilderness might be the better word.
It might feel like that for a while.
Yeah, that's right.
But lots of people wishing you well from the Space Nuts fraternity. So, yeah, you've been busy. You've been down in Victoria, which is one of the southern states of New South Wales, talking about stuff. Actually, somebody was there and posted a picture of you on Facebook, I think it was, one of our Space Nuts audience.
That's nice. I look at Facebook from time to time, shouldn't I, and find out what's going on in the universe or whatever it's called.
Yeah, whatever it's called.
I've lost the plot altogether now. That's just a bit of jet lag coming back from deepest Victoria last night. I'll tell you one thing. One thing I saw, and I was actually at this place. This is Sea Lake is where we were doing the Astrofest. It is a little town, and it's right next to a lake that looks like a sea, which is why it's called Sea Lake.
As in the letter C?
No, the SEAC.
Right. So that's too much of a coincidence.
Yeah, well, it is a coincidence. It's often called a sky mirror because the Burong people, the First Nations people who are indigenous there, they used to have legends that it was a mirror of the sky because it's a salt lake. It's dead flat, very, very smooth when it's full of water. It wasn't that full this weekend, but when I saw it last year, it was more impressive. There's a lot more water in it. But something I did notice last year and followed up because I had no idea what it was, but we had a much better look at it this time, is a solar concentrator, which is just south of Mildura. And this is a power station that involves solar panels of a very different sort. They're steerable mirrors. There are 4 of these towers, each one surrounded by an array of steerable mirrors that can point the sun's light to the top of the towers. And there is a working fluid, and I haven't checked out what it is yet. It could be water, but I think it's more likely to be something else. That is turned instantly into steam because of the heat, the intense heat, and that drives turbines, so you generate power. But it is quite an extraordinary sight to see them when you're going up the highway towards Mildura. It's what caught my eye last time. And as I said, I followed it up, and we went and had a look at them. Quite an amazing piece of technology with this dazzling blob of light at the top of each of the towers where the sun's light is focused. And also managed to get an aerial shot of it from our flight down to Melbourne, coming back home yesterday afternoon. So I know what it looks like from above as well.
I didn't even know such a thing existed. Quite amazing. I also, while we're talking about that kind of thing, I saw a story this week where the CSIRO, which is the Australian Government Science Department, has started producing flexible solar panels, which could change the game completely in terms of power generation. So that's pretty exciting news as well. You could wrap them around a Coke can and keep it cold or heat it up or whatever you like.
Or you could wear them.
Or you could wear, yeah, well, that's the thing. You could. I know they put little solar panels in caps sometimes so they can turn on a fan and keep your face cool, that sort of thing. But this is a much bigger thing in the power generation game. Yeah, it's all very exciting. We better get on with it, Fred, and we're going to start off with a couple of stories from Mars. Now, what's this Mars message all about that was sent back in 2023 and has only just been decoded?
So it was part of a sort of celebration. It was an art project, something called a Sign in Space, a multi-week art project led by Daniela De Paulis, who's the current artist in residence at the SETI Institute. Now, you remember the SETI Institute, Search for Extraterrestrial Life. They're in Mountain View, California, and they are very long established. They've been going for a long, long time. They actually have facilities. They have their own telescopes that they run, and a lot of very, very significant scientists who work there, some of whom I know. But I don't actually know the artist in residence. But what happened was this Sign in Space test, which was basically carried out by the European Space Agency's ExoMars Trace Gas Orbiter probe, that was launched quite a few years ago. Actually, it's one that was looking for methane in Mars's upper atmosphere, and I don't think they found it there. We know it's there on the surface, but not so much in the atmosphere. Anyway, the idea was to think up some sort of signal that we might receive from an extraterrestrial intelligence. And so this was a sort of coded signal that was broadcast by the Trace Gas Orbiter in orbit around Mars and picked up on Earth and then sort of sent out almost like a citizen science project for people to have a look at and see if they could decode it. And the bottom line, and the reason why this is in the news, it's now been decoded by a father-daughter team. She's lovely. Ken and Kelly Chaffin are their names, or Chaffin. And apparently, and this is a quote from the ESA statement about this, they followed their intuition and ran simulations for hours and days on end and finally came up with a decoded signal. And once again, the ESA statement, I haven't actually checked out the ESA statement in detail, just not had time since we got back. But it contained movements. That was the thing about this decoded message. It contained movement which suggested to the Chaffins that it might contain information about life, because life tends to move. And so what they've got to do now, having decoded it, they've got to work out what it means and find the possible meanings in this message. And that's apparently the overall, that's the main goal of this project, the Sign in Space project.
Yes.
There is a nice quote from the artist in residence who said, "Receiving a message from an extraterrestrial civilization would be a profoundly transformational experience for all humankind. A Sign in Space offers the unprecedented opportunity to tangibly rehearse and prepare for this scenario through global collaboration, fostering an open-ended search for meaning across all cultures and disciplines." So it's a very nicely, formulated project. And it looks as though we're halfway there now.
Yeah.
So find out eventually what it means.
Yeah, and well done to Ken and is it Kelly or Keeley? Who decoded the message. Decoding doesn't mean, as you said, we understand it. Now they've got to actually figure out what's within the message. But it does kind of sort of ring of the movie starring Jodie Foster called Contact, which was exactly that scenario where we received an extraterrestrial signal, and a lot of the time, it was a very long film, but a lot of the time was dedicated to deciphering the film and working out what the messages were, and ultimately it was the building of a spaceship type scenario, a wormhole generator or whatever you want to call it. But if the day ever came where we received a message, that may well be the challenge, is figuring out what's in it, because it's okay to receive something, but that doesn't mean you're going to understand it. And that's what this was all about. It's quite extraordinary. What a clever concept to come up with.
Yeah. There's a nice report about this on the space.com website, and the author has almost become poetic, because there's a very nice sentence here. For all we know, alien communication might more resemble a collection of odors or the movements of a pile of leaves in the wind than anything we recognize as language. It's beautiful, but I agree with you. In fact, Contact's one of my favorite sci-fi movies because of that. Well, it's exactly all about linguistics.
It is. That, and there's another one, I can't think of the name of it, where they, Earth was visited by an alien species, squid-like creatures, and the communication barrier was basically the guts of the film, because they couldn't figure out how to talk to each other. And that's brilliant. I can't think of the name of it. Anyway, it'll come to me, or someone will message us and tell us. But I love this story for that very reason, because even on Earth, though, Fred, you said it, there is communication on Earth that does just that. Like dogs and cats and other animals do communicate with odor more so than they do. Right. Yeah, spoken language, and many other creatures communicate with signals, whether it's mating or whether it's just day-to-day communication. It's something to consider. Imagine getting a video message from an alien race and they spoke in sign or something like that.
Yeah,
to try to figure that one out. Yeah, it's extraordinary. Space.com is where you can read that amazing story. Let's take a little break from the show to tell you about our new sponsor, Saily. Now, as you're probably aware, my wife and I have done a fair bit of travelling in recent times. One of the pitfalls we find is internet access, especially when we're out and about and we want to stay in touch, or we want to send a photo to the kids, or we want to do a Snapchat or something like that. Most recently in Turkey, we bought international roaming from our current carrier, which was not cheap. And we did the same some years ago with our previous carrier, which was even more expensive. I mean, some of these things can run in at $10 a day, which is an awful lot to pay for very limited services. So what's the better option? The better option is to buy yourself an eSIM from a company that specialises in overseas internet connectivity, and that is Saily, Saily. Now, Saily is an organisation that's available through 160 countries and 8 regions around the world, which gives them a very strong presence. It's also not expensive. If you're travelling internationally soon and this is something you'd like to get hold of, bearing in mind there's a big discount at the moment for Space Nuts listeners, just download the Saily app on your device, whether it's Android or Apple. Choose your plan and don't forget to use the code word SpaceNuts when you're ready to pay, and you'll get a 15% discount. That's the Saily app. Download that on your device. And they have 24-hour, 7-day-a-week support. And if it doesn't work, you'll get a full refund. But they're pretty sure that you'll get the best out of their service. So if you're traveling soon and you need access to the internet via a carriage service in another country, this is the way to do it. Download the Saily app today, choose your plan, and don't forget the Space Nuts code word for that 15% discount on the Saily service wherever you're going in the world. I'm sure you won't be disappointed. It's backed by NordVPN, a great company that backs its products 100%. Find out more about Saily in our show notes. Now, back to Space Nuts.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
While we're talking about Mars, Fred, let's move on to a completely different situation. And this looks at the ancient history of Mars in terms of its carbon dioxide, which is quite prevalent on the red planet. But at some stage, there was a change in the planet, and we all thought it was like a global warming type of an event, which has seen a lot of the CO2 end up in the regolith. But there's a new study out that's saying, hang on a minute, we think it could have happened another way.
Yeah, that's right. So you're quite right. That's, we think of Mars as having had a warm and wet past, and the evidence seems to be there. And then what came after that was, we don't know whether it was dramatic or whether it was a sudden end, or whether all the water evaporated into the atmosphere and to become dissociated into hydrogen and oxygen and be lost. We know a lot of it is still there as ice under the soil or regolith of Mars. But there's a model that has basically been, it's developed by a researcher by the name of Peter Buhler, I think Buhler, at the Planetary Science Institute in the USA. And
he's related to Ferris.
Right. Right over my head.
No, people don't know what I'm talking about. That's another movie reference. Ferris Bueller's Day Off.
Right. Okay. You watch too many movies, or I don't watch enough. I'm not quite sure which it is.
Yeah, it's probably true.
Both. I think both are true. All right. Okay. Having put that one to bed, Peter Buhler, not Ferris Bueller, he's built a model of the way Mars's atmosphere works. In terms of its carbon dioxide cycle. And we've known about this for a while. I have read before about the way carbon dioxide sort of crosses between being a gas and being solid. And, it depends on the season and things of that sort on Mars. So Buehler's carbon dioxide cycle is all about the interchange of carbon dioxide, again, with this soil, so that you can actually get the soil forming a thin coating of solid carbon dioxide on each grain of soil if you've got the right sort of weather conditions. And then that, in heat, when it's warm, that carbon dioxide goes into the atmosphere. It gets warm enough to stop being a solid and become a gas. And then it can migrate from the atmosphere over to the polar caps, where it's cold again, because they're the poles, and you get it freezing out. So we know that some of the ice on the polar caps of Mars is solid carbon dioxide. However, what Dr. Buhler has done is looked at what might have been happening when Mars did change from being a warm, wet climate to a cold, dry one. And the work that he's done is quite interesting in that it highlights an aspect of the Martian liquid water that we know was on the surface in a way that we have not thought about before. And I'm going to quote him, actually, because that's it sums it up very nicely. Peter Buhler says, "This model describes the origins of major landscape features on Mars, like the biggest lake, the biggest valleys, and the biggest esker system." And eskers are the remains of rivers that once flowed beneath ice. I remember that from my school days when we studied those things. So the biggest esker systems in a self-consistent way. And it's only relying on a process that we see today, which is just carbon dioxide collapsing from the atmosphere. And so what his model says is that the carbon dioxide that's actually locked up in the regolith, the Martian soil, in warm conditions, that will escape and will freeze back, and may well freeze back onto icy regions. Now, we know that probably Mars was covered, not all of it, but a lot of it was probably covered by ice early in its history. And his suggestion is that a layer of solid carbon dioxide on top of the ice actually acts as a blanket. It's a thermal blanket, which means that the the ice underneath it basically doesn't lose the heat out into space. And so because of the residual heat from the interior of Mars, which warms the underside of the ice, you might very well get liquid water underneath a layer of ice, underneath a thin layer of carbon dioxide, which is keeping the heat in. And then if you've got lakes and rivers underneath that ice, then they're going to form the sort of landscape features that Peter Buhler is talking about. So it's a complex picture, but it basically it suggests there's a kilometre of carbon dioxide on top of something like 6 kilometres of water ice. And then underneath that is running water, which is really quite an extraordinary scenario.
Yeah. Is this going to be subject to peer review, or are they pretty confident they've got this right? Because what they're saying is, look, we've had this preconceived idea for a long time about how things might have transpired on Mars, but they're throwing up a completely different scenario.
Yeah, that's right. I think it's actually in the Journal of Geophysical Research, but I'm not sure whether it has got through peer review. I suspect it has. I haven't looked closely enough at that. The title of his paper it's a lengthy title, Massive Ice Sheet Basal Melting Triggered by Atmospheric Collapse on Mars, Leading to Formation of Overtopped Ice-Covered Argyll Basin Paleo Lake, Fed by 1,000-kilometre rivers. There you go. That's the story. Good language.
You just read the whole paper.
That was just the title.
Yeah. But one or two of the interesting things that I gleaned from this is what Mars used to be like, and they say it had oceans the size of Earth's Mediterranean Sea, for example. It's just hard to imagine when you look at it now.
That's right. I mean, when you look at Mars, on a topological map, you see how low-lying the northern hemisphere is, and it's very easy to believe that was perhaps covered with an ocean. It's also very sparsely cratered, the northern hemisphere, which means it's a relatively recent surface. It's a particular region that Peter Buhler's paper is referring to, the Argyll Basin. It is about the size of the Mediterranean Sea. And the thought is that that was once covered with ice, but with water underneath it, and basically draining to the northern plains of Mars. It's really quite an extraordinary idea. But what he suggests also is that this might have happened multiple times. You might have had this suggesting it might have happened millions of years apart during an era that might have lasted for a tenth of a billion. In other words, 100 million years. So it is quite an interesting scenario that may well have given rise to some of these features that are otherwise difficult to explain in the landscape of Mars.
Yeah, they also reference the rotational tilt cycle of Mars and how that might have been a factor, because it does sort of every 100,000 years move into different positions, and that can affect what's happening with the CO2 cycle, I think.
Yeah,
we were saying.
Because the difference of solar radiation, that's right. And that's one of the things, that highlights how important our moon has been in our evolution, because the Earth doesn't do that, because the moon stabilizes the Earth's tilt. Mars doesn't have that, and so its tilt has wandered around, as you said, with a periodicity in the region of 100,000 years. So
so when God built Mars, he just put two tiny little rocks there to stabilize it, and went, oh, damn, that didn't work. Let's try again.
I didn't know she swore. I didn't know God swore like that. Anyway, whatever happened, and those two moons, they were probably collected by Mars later, and one of them's not going to last very long because it's going to crash into the planet. So, interesting stuff. And it does highlight the difference, doesn't it, between our own planet and, well, every other planet pretty well.
Yes, it does. But the similarities between Mars and Earth are quite eerie in certain respects. You talk about how the oceans would have dominated one hemisphere on Mars. It's similar on Earth, because basically the southern hemisphere is a lot wetter or waterier than the northern hemisphere in terms of ocean size and geographic layout. And so many other things, the canyons and the Earth and Mars are so similar in many, many ways, except Earth's a much bigger planet, but the features on Mars are incredible. And indeed quite Earth-like in many ways.
Yeah.
And I gather that Venus probably was at one stage like that as well before the runaway greenhouse effect messed it up completely. So
maybe so.
Yeah, quite amazing. You can read all about that story at the phys.org website. This is Space Nuts with Andrew Dunkley and Professor Fred Watson.
Roger, you're loud and clear here also.
Space Nuts.
Our final story today, Fred, is surprising in that we finally get to talk about black holes.
I've missed the black holes, I have to say. I've missed them.
Yes, we haven't talked about them for maybe a week, maybe that. But this is quite a staggering discovery. This is a black hole that is basically defying logic by eating more than it would be capable of eating. A lot of people do that. We have an obesity epidemic in this planet. But this is a gargantuan situation where there's a black hole they've discovered that is munching on so much stuff. They have gleaned that it can't eat that much. So how do you explain it?
Yes, that's right. So clearly it is doing. So how do you tell when a black hole is gobbling up stuff? It is basically surrounded by so much infalling material, so much stuff swirling around, that stuff is energized to high levels, which means that it emits radiation, and a lot of it comes up in the X-ray region of the spectrum. So if you've got something that's very bright in the X-ray spectrum, you might be expecting that you're talking about as something that's being, a bunch of material that is being energized by a black hole and is falling into a black hole. And that's how this story starts, Andrew, because it's a group of scientists led actually by scientists at the International Gemini Observatory, and that's operated by the National Science Foundation's NOIR Lab, which is the National Optical Infrared Laboratory. And so astronomers there have looked at not just the optical astronomy that they are normally working on, because all those are optical facilities. They've basically observed a set of galaxies that have come from an X-ray observatory, which is in orbit around the Earth. It's called Chandra. Chandra did a survey of bright X-ray galaxies. And so what these astronomers have done is taken that set of galaxies and then used another facility, which is not X-ray, but that's the James Webb Space Telescope, which of course looks in the infrared, to observe them. And there's an instrument on the James Webb Space Telescope. It's called an integral field spectrograph, which does what we sometimes call hyperspectral imaging. When you're looking at the Earth from space, you do hyperspectral imaging. When you're looking at the universe with the same instrument, you call it integral field spectroscopy. But they're the same thing. What you're doing is you're making an image, but for every pixel in the image, you're making a spectrum. So for every pixel of light that's in that image, you can look at the distribution of the light with wavelength and reveal that barcode of information that we often talk about, that is basically the key to understanding the source of the light and its and what it's passed through. And so they've done that, and they've found one particular galaxy by the name of LID 568. Sounds more like a car rego to me, but that's also the name of a galaxy.
Funnily enough, one of my first vehicles had the number plate LDI.
There you go. See what I mean? Yeah. Yep. So LID 568, which, could be a Chevy, it could be a Mercedes. I don't know what it is. Anyway.
Mine was a Mitsubishi Magna.
Yeah, I used to have one of those. Yep. Anyway, never mind. That's all aside. This particular galaxy, which we're seeing, the look back time is basically about 12.3 billion years, which means we're seeing it when the universe was about 1.5 billion years old. It's very bright in X-rays, and it tells you that there's a lot going on there. And so with this integral field spectrograph on the James Webb Space Telescope, what they were able to do was find that there are amazingly powerful outflows of gas around the central black hole of this galaxy. And what that suggests, these outflows, of course, come from the magnetic field around the galaxy. It's around the black hole. We're often questioned by our listeners about, so if nothing can survive being pulled into a black hole, how come they radiate X-rays and how come stuff comes out of them? And that's because of the magnetic fields that they generate. So what they've done is looked at these outflows of gas. But the bottom line here is that it looks as though when this thing was really actively gobbling stuff up, it sort of all occurred very quickly. In other words, it amassed a lot of material very quickly, so that this black hole might have grown to supermassive proportions over a very short time. I'm actually going to read it again. We've got this on phys.org, a very nice account of what is happening here. So I'm quoting here from phys.org. In a stunning discovery, Sue and her team, it's SUH, that's the astronomer leading this. Sue and her team found that LID 568 appears to be feeding on matter at a rate 40 times its Eddington limit. This limit relates to the maximum brightness that a black hole can achieve, as well as how fast it can absorb matter, such that its inward gravitational force and outward pressure generated from the heat of the compressed infalling matter remain in balance. When LID 568's luminosity was calculated to be so much higher than theoretically possible, the team knew they had something remarkable in their data. The black hole is having a feast. That's a quote from one of the co-authors. This extreme case shows that a fast-feeding mechanism above the Eddington limit is one of the possible explanations for why we see these very heavy black holes so early in the universe. That's the crucial point of this paper. This is a clue to the fact that, whereas we thought that black holes grew to be supermassive over a very long period of time, it looks as though they can gobble up stuff very, very quickly early in the history of the universe, which might really illuminate this conundrum that some people have pointed out, that galaxies look as though they're more highly evolved very early in the universe than they ought to be. This might be the reason why.
Fascinating, yeah. And so in terms of eating more than they're capable of, obviously they're disposing of stuff so that they can keep eating at the same time.
That's right. Yeah, that's right. So and what it's saying is that, the Eddington limit comes about because you expect there to be a balance between the gravitational pull of stuff coming in and the pressure that the radiation is pushing it out with. This obviously exceeds the Eddington limit, which means that basically it is eating more than it can cope with. So a lot of stuff's coming out. I mean, I'm sure there are parallels that we can put in human digestion, but I'm not really going to go there, Andrew.
I've actually witnessed a comparative scenario as yesterday when we were babysitting the grandchildren. Young Harriet was eating a packet of chips, and as she was eating, all this debris just kept falling on the ground. It was quite incredible. Yeah.
Yeah. Okay. That's probably as far as you want to go with that.
Yeah, I think so. Yeah, yes. It was extraordinary to watch, I must say. I was thinking black hole at the time. This is another weird coincidence, Fred. This is 2 weeks in a row where you've read a quote that I'd highlighted to bring up with you at the same time as you started reading it. So I think we're becoming symbiotic.
We must be. We're probably entangled, Andrew. That will be one for quantum physicists. In fact, that would be good because soon we'll be able to talk to each other faster than the speed of light if we're quantumly entangled. That'll be fine.
Yes, we'll be able to end the show before it began.
I thought that always happened.
Pretty much. But no, fascinating story. And again, from one of our favourite sources, phys.org, if you'd like to read up on that. Oh, and by the way, Fred, I remember the name of that movie that we were talking about early on.
Oh, good.
The one where the aliens arrived seeking our help, but we couldn't understand what they were saying. Arrival. It was called Arrival.
That's correct. That was a good one. Yeah. It was
and you couldn't take your eye off it, or you'll go, "What? I don't know what's happening now." If you can't lose focus on that film. It is so complicated, or at least for someone with my brain, anyway.
The homework for me is to find out who Ferris Bueller was.
Fair. It's a really good film. It's got a cult following. I do enjoy it. I haven't watched it for a long time, but I feel like watching it again. Thanks, Fred. We're all done and dusted. Good to talk to you.
Great to talk to you too, Andrew. And I hope you have a good rest of the day.
Indeed. We'll catch up with you very soon, perhaps. Very soon. Professor Fred Watson, and Hugh in the studio didn't turn up today. Apparently he had to take the dog to the vet to get the nails clipped. I can hear it from here. And from me, Andrew Dunkley, thanks as always for your company. Don't forget to share us and spread the word about it, and bring more of your friends and relatives on board as space nuts. And from me, Andrew Dunkley, farewell. We'll catch you on the very next episode. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.